Yeah. 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 I can't do that. Okay. I'm looking at f of x. I'm going to estimate where this function is increasing. Somebody tell me. Negative infinity to -5. Is everybody okay with that? Where else? Where is it decreasing? Estimate. I'm looking at f of x, not f prime. Where estimate? Where is it concave up? Where is it concave down? Okay, let's go -2. That's fine. To infinity. Concave down from negative infinity to -2. So what Gigi is saying here is if you locate approximately at that spot, looks like where it changes from concave down to concave up. Nope, still on its way up. If you look at the tangent lines, they would continue to draw the tip up. If you look at the tangent lines, continue to be drawn down. Drawn up, drawn down. Local max, estimate the location of the local max. X equals -5, sounds good. Could we list the y value as well? We could. We're not going to in this exercise. Local min. And where would you estimate as the point of inflection? We already said x equals -2. So you will not get that question on the test. But the next question, as Grace brought up, she kind of, right away, she's like, well, I thought we were looking at f prime of x. Now we're going to look at the same function, but we're going to call it f prime of x. So we want to know where f of x is increasing. Yes. Yeah. So if I were to draw this tangent line right here, okay, and I draw another one, and I draw another one, do you see that they are dropping? As I move left to right, the tangent lines are dropping. So therefore, it's concave down. Whereas here, if I draw the tangent lines, they are rising. Therefore, it's concave up. Yeah, good. I would say, and this is what Zach pointed out yesterday. We were kind of talking about this on the board. Is that as you look at, say, the tangent line there and there, that at -2 is when it seems to get most negative. And then after that point, it starts to tip up. So it's dropping, and then it starts to pick itself back up. Is that you can see the language I'm trying to use. It's not the easiest thing to try to explain and think through. There's a lot of different ways to think about it, but that's one. Seems to work for some people. Okay, so we look at f prime of x. We have to consider the definition of increasing. A function is increasing when f prime is, when is f prime positive? -8 to negative, whoa, that was not a -8. -8 to -1, union with 5 to infinity. Where is it decreasing? -1 to 5. Okay, I want to forget about the concave up and concave down for a second. Let's look at the local max and local min. Local max occurs when f prime changes from positive to negative. Where does f prime change from positive to negative? A local min occurs when f prime changes from, when does it change from negative to positive? So if I look at a local max, you can see that the derivative changes from positive to negative. Agreed? Well, if you look here, this is the derivative graph. Better? Okay. All right. So now we're going to get to the a little bit more challenging part, which is to consider concavity. So if I want to show the second derivative, I would draw a tangent line to the first derivative, correct? So as I draw a tangent line right here, you tell me, is the second derivative positive or negative? Second derivative is positive. So I draw a tangent line here. Is the second derivative positive or negative? Negative. So we said that concavity is where the second derivative is positive. Can you tell me where the second derivative is going to be positive? From where to where? Negative infinity, negative 5, and then from 2 to infinity. Good. Concave down. Yeah, so wherever, so this, the graph is the first derivative, right? So the tangent lines would, the slope of the tangent lines would be the second derivative. So wherever the slope is positive, that means the second derivative would be positive. So it's concave up wherever the second derivative is positive. So as you consider here, you know, from 2 to infinity, you can see that the slope is positive. Concave down wherever the slope is negative then. Negative 5 to 2. Inflection is where concavity changes sign. Where does concavity change sign? X equals negative 5 and 2. And I'm sorry, I said that incorrectly. Where concavity changes sign, where the second derivative changes sign, or it changes concavity as a whole. Yeah. Better? Got it? Yes, the concavity piece or the inflection. So inflection is going to happen wherever the second derivative changes sign. The second derivative will be the slope of the tangent lines. And you can see here the slope is positive, here it's negative, so it changes sign right here, which is at negative 5. Then it will again at positive 2. Okay, before we look at f double prime, I'd like you to do f prime on your own. Check it out, compare with a partner, see what you get. Try this one on your own. Okay, does it look okay? All right, good job. You can see this is a very complicated graph here. I would say, you know, the ones that you're more likely to get on the AP exam would be, you know, something like this one that we first did right here, okay? This one we're given f double prime. Does f double prime tell us anything about increasing or decreasing? Doesn't tell us anything about increasing or decreasing. We can't really determine any information from that. But we can determine concavity. What is the definition of concavity? Wherever the second derivative is positive. When is the second derivative positive? Negative infinity to what? Negative 3. Union with 8 to infinity. Definition for concave down is where the second derivative is negative. When is the second derivative negative? Local max and local mins happen when the first derivative changes sign. We don't know when the first derivative changes sign, so we cannot determine those. We can determine inflection, and inflection will happen where the second derivative changes sign, and that happens at x values of it's okay. Well, the local max and local min, again, the definition is where f prime changes sign. Do you see f prime up here? We don't. We could go forwards, like if they asked us questions about F triple prime, we could draw tangent lines, but going backwards at this time would be very difficult for us to do. We would need more information. So in terms of inflection, inflection is where F double prime changes sign. And F double prime changes sign there and there. Okay? I want to be clear. In order to do these kind of problems, you have to. The way that the AP exam is structured is you have to go back here. Remember when we wrote out the definitions? You have to think of the definitions. Don't get caught up in the shape of the graph. Say to yourself, where is F prime positive? Where is F prime negative? Where is F prime change sign? And the proof is in the problem right here. I'm going to give you 1 minute. You look at the problem with your partner. This is pulled from an AP example. It is pulled from 2012. It was problem number 80 in 2012. And I want you to understand, I've done every single multiple choice problem from back till 1960, released from the AP exam. I've seen them all, okay? And I sort them accordingly. It's time for us to start looking at them. You got 1 minute to come up with an answer, 1 minute and 30 seconds we're going to give you. Come up with an answer A, B, C, D, or E. Think about example number 2. Go. And stop. Let's talk about it, okay? You see the problem. It says F has a relative minimum. The first and most important piece is you recognize you're looking at F prime. The definition for a relative minimum or a local minimum would be when F prime changes sign from negative to positive. Does it change from negative to positive? Yes, it does. Right there at -3. So that one is in. Number 2, the graph of F has inflection point x equals -2. Inflection happens when the second derivative changes sign. The second derivative does not change sign at -2. It's positive all the way through, isn't it? Where is the spot where the second derivative changes sign? At 0, the second derivative goes from positive to negative. Very good. So therefore, this one is out. Now, if you thought that this was the graph of just F, yes, it looks like it changes from concave down to concave up right there. So if you thought that it was F, it does look like it has inflection. But in fact, it does not. Graph of F is concave down from 0 to 4. Well, that would require for F double prime to be less than 0. F double prime will be the slope of the tangent lines. Are those all negative? Yes, so that one is true as well. So E is your correct answer. You have 1 minute to do the next one. Go. Okay, this problem is nicer because it tells you it wants the local maximum. You focus on the definition. Also, understand you are looking at F prime. The definition, F prime changes from positive to negative. That occurs at 1. The answer is C. You try example 4. You have 1 minute to do number 4. No, we'll go 1.5. Go. 4. This one right here, we are looking at F double prime. Most important thing is when you get to the test, you recognize that you're looking at F, F prime, or F double prime. Well, it's asking about concavity, concave down. Now, a lot of people would say, well, it's going to be concave down here. Well, that would be if it was F, right? It's not F. So then people would be like, oh, well, concave down wherever the derivative is negative, so we're going to look from there to there. That would be if you were looking at F prime. But since we're looking at F double prime says wherever F double prime is less than 0, it's concave down. That'll be here and here. From -2 to -1, and then from 1 to 3, E is the correct answer. Number 5. 1 minute, 45 seconds. A little bit tougher. Go. This is one that many people would need to set aside and try to come back to later. This would be one that a lot of people would guess. Naturally, people are drawn right towards F is increasing. And the reason why is the definition is that F prime is positive wherever it's increasing. These are all positive, aren't they? However, here's the trick. That's incorrect. Because look at this. At -1, is it possible that the value of f prime would be -3? They don't give you the value at -1. They tell you for these values it's positive, but you don't know what happens in between. You don't know that for sure. And so that's tough. Okay? Notice graph of f is concave up. That would be if f double prime was always positive. Okay? We're not given f double prime, but we could consider f double prime. F double prime is going to be the rate of change of this, right? Is f prime going up or down here? It's going down, up or down here. Up or down here. Up or down here. Down. So this is f double prime. We know a little bit about it. So it changes sign once. It changes sign twice. It has at least 2 inflection points. Letter B. I will show you right after we do this one. This is your last one for the day. See if you can knock it out of the park. 1 minute, 45 seconds, go. 0. Here we go. Are we given f prime, or f double prime? F double prime. So naturally, we are drawn to 2 ideas. We are drawn to concavity, and we are drawn to inflection. So right away, I want to consider these 2 possibilities. Now, at first glance, many people will say that it has inflection at 1. And they would be right to think down that line because they're like, well, it goes from 5 to 0 to -7. So that means it goes from positive to 0 to negative. But here's the problem. It might go positive, 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 0, positive, 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 0, negative, negative. Like they don't show you everything in between the values of 0, 1, and 2. So we do know this. And this is very simple. At 0, it's positive. At 2, it is negative. So over the interval of 0 to 2, does it change sign? So it must have concavity change over the interval 0 to 2 at some point. Okay?